Okay, so moving on from prime numbers, we're going to talk today about the greatest common factor. And the reason why we use the greatest common factor is when we simplify fractions. We're going to divide out common factors. And so if we divide out the biggest common factor, then we'll be done simplifying the fraction in one step. Okay, so today we're just going to practice finding the greatest common factor, and we're going to use our prime factorization to do that. That's one of the reasons why we learned it. Okay, so let's suppose we wanted to know the greatest common factor between the numbers 12 and 30. So we're going to say find the GCF, greatest common factor, of 12 and 30. So what we'll do first is we'll make a factor tree for each. Okay, so we'll start off with our factor tree for 12 over here. Okay, so I'm going to start with 2. 2 times 6. Bring down the 2 because it's prime. Write 6. That's 2 times 3. Okay, so I'm going to stop right there. And then for 30, do that in green. I'm going to start with 3, and I'm going to rewrite 30 as 3 times 10. Carry down my 3. Write my 10 as 2 times 5. Okay? So we've got them both written as their prime factorizations. Now we need to circle the numbers, the prime numbers, that are factors of each. So I see 2 is a factor of each. Now since there's not another 2, even though there's another 2 for the 12, there isn't another 2 for the 30. So we get to skip over the 2, and then 3 is also a factor of both. Okay? So the greatest common factor, then, the greatest common factor is 2 times 3, or 6. And sure enough, when we think about it, 6 goes into 12 and 6 goes into 30. So it is the greatest common factor. And later on, you don't have to do this now, but just so you recognize the point here of why we're doing this, if we wanted to reduce 12 over 30, we would divide a 6 out. 6 goes into 12 twice. 6 goes into 30 5 times. So 2/5 is the simplest simplified fraction. Okay, but we don't have to worry about this now. All we're going to do today is practice greatest common factor. Okay? I'm going to show you another way to do it, the way your book does it. They would take 12 and they would sort of do it in their heads. They'd say, okay, 2 times 6, but I know 6 can be written as 2 times 3. And then 30 is 2 times 15, but 15 is 3 times 5. Okay? And then we can circle these and circle these. So if you're sort of comfortable with that shortcut, then go ahead and use it. Okay? But if you're more comfortable making the factor tree, okay, when you get down to the end of your factor tree, you just circle the common factors and then multiply them out, and that'll give you your answer. All right, so we'll do a couple more here. Let's try another pair. How about 16, 32, and 40? Okay, so now we want the greatest common factor of all 3 of these numbers. Okay, so we'll start with 16, and I'm going to write that as 4 times 4, and then 2 times 2, and 2 times 2. So 16 is the same as 2 to the 4th. And then 32, okay, I'm going to write that as 4 times 8, and then 4 is 2 times 2, 8 is 2 times 4. I'm going to bring down my 2's, and then 4 can be written as 2 times 2 also. So 32 is 2 to the 5th, isn't it? 16 is 2 to the 4th. Okay, now 40, how about 5 times 8? Okay, and it doesn't matter, we don't all have to do this the same way. Bring down the 5, right? 2 times 4, bring down the 5 and the 2, and now we've got 2 times 2. Okay? So circle the common factors. Wow, well look at this. There's 3 2's here, 3 2's here, and 3 2's here. Okay, so the GCF, what would the GCF be? Can you do 2 times 2 times 2 in your head? GCF would be 2 to the 3rd or 8. Now let's just check and make sure. 8 goes into 16, yup. 8 goes into 32, yup. And 8 goes into 40. So that's it. Okay, fantastic. Last thing, what if you have the numbers, let's say 16 and 25, and you're looking for the greatest common factor. Now notice those are both composite numbers, right? 25 is composite because it can be written as 5 times 5. It's not a prime number. 16, we just found out, right? 4 times 4, and then 2 times 2, and 2 times 2. It's written as 2 to the 4. Notice that these numbers have no common factors. So we say they are relatively prime. They're not prime numbers, but relative to each other, in other words, compared to each other, they're relatively prime. They have no common factors. All right? Okay, last thing. We haven't talked about terms with variables, but we can go ahead and add variables to our number. So if we look at 18, let's say xy squared, and 28 x squared y squared. So now we're not only considering the biggest number that goes into 18 and 28, but we're also considering the biggest power of x that goes into both and the biggest power of y that goes into both. Okay? So 18, we can write, let's see if we can do it this way. Okay, I know it's 2, 18 is 2 times 9, and I know 9 is 3 times 3. So I'm going to write 18 as 2 times 3 times 3, and then I'm going to write times x times y times y. Okay, so I'm taking my monomial. It's called a monomial because it's one term, and it's made up of more than just numbers. It has a variable part too. So we're comparing monomials. I think that's a new word for you. Okay, now we're going to look at 28 x squared y squared and do the same thing. Let's see if we can do it in our heads. I know 28 is 7 times 4. 4 is 2 times 2, so I've got 2 times 2 times 7. Is that right? I think so. Times x times y times y. Do you understand? Okay, so now I can circle the 2 here. I can circle these x's. Okay, and then both y's like this. Whoops, I made a mess out of that. So the greatest common factor here would be 2 times x times y, or 2xy squared. Okay, and let's check. Sure enough, 2 goes into both 18 and 28, and x goes into both 18xy squared and 28x squared y squared. And y squared also divides into both once. Okay, fantastic. Thanks for listening. See if you can do your homework now.